All right, so let's go through the steps here. The first step, like you know, is in your notes, is to plot the points. So let's do it. So you look at the points, 2, -3. So A is at 2, -3, 2, 1, and 2, 9. So there's 2, 9. Here's 2, 1. And here's 2, -3 again. First number is horizontal, second number is vertical. Okay, it's -7, -3. So -7, -3. And then -1, -3. So plotting these points, A, B, C went like this. So here's A, here's B, here's C, and then D here and E here. So you got your triangles, and so I'm just going to outline the triangles that they give me. So A, B, E is here. So here's A, B, E. So there's our first triangle, okay? The other triangle they give me is ACD, and I'm trying to prove that these two triangles, so AC, and then D is over here. So it's this big one I just outlined in blue. All right, so you got two triangles, ABE and ACD, that you're trying to prove are similar. So like we said, you plot the points and you look at them, you're like, okay, so like we did with the first one, this is going to be a side angle side relationship, if anything. So what you got, step one, plot the points. Step two is distances, right? So you're going to find the distance of all the parts that you need. So when we did this the first time, the green triangle, I'm going to find two distances. I'm going to find AB and AE. Okay, and in the blue triangle, I'm going to find AC and AD. And I'm looking at this because I want to prove side angle side, because I see that both of these triangles share this angle right here. So I'm going to prove that those triangles are going to be similar by side angle side. So distances, so I'm going to write down the distance I'm trying to find. So it's AB and AC. So I'll label it. So AB is the side in this triangle, the green one. And then I want to see if it corresponds to AC in the same way that AE in the green triangle corresponds to, if you look at the name, AE corresponds to AD. So I'm going to find these four distances, and I'm going to see if the ratios are going to be the same. So let's go ahead and look at this. It's actually going to be pretty easy. Actually, I don't really need the distance formula here, okay? If you look at these, AB, if you just count, if I could highlight this, AB is the distance from 2, 1 to 2, -3. So you're like, well, how far apart is that? You could literally just count, like 1, 2, 3, 4. You see, like, between negative or positive 1 and -3, the distance from A to B is 4. Okay, if you did the distance formula, you could do that. The change 2 to 2, if I look at the 2 points, here and here, the difference between 2 and 2 is 0. So you can square, you can do your distance formula. So square of 0, the difference between 1 and -3 is 4. So the square of 4 squared, which like that's just going to be 4 the same way. So I can just count, or I can use distance formula, whatever you like better. I'm going to do AC now. And again, AC is just straight up, this time from 2, -3 to 9. So -3 to 9, if I just think, okay, 9 minus -3, or just count, that's 12 units. So that's how you're going to find AC. So AC is 12. All right, continuing on, I'm going to do another way for AE. So AE goes from 2, -3 to -1, -3. Okay, so now I'm looking at the x's. I'm looking at -1 and 2. I'm saying, okay, -1 minus 2 is -3. So I know that is a distance of 3. So AE is 3. And then AD, I look at it the same way. Okay, AD is from 2, -3 to -7, -3. So I'm like, well, how far apart are -7 and 2? And you're like, well, that's -9, but I'm going to make it positive. So the distance is 9. Again, you can just count this. So from A to D, it's just 9 units. Just count it, look at the number line, and just figure out that's going to be 9. So now, I've taken care of steps 1 and 2, and I'm going to figure out if I have the same ratios. So step 3 is check your ratios. All right, what I mean by that is I'm going to look at AB, and again, I'm looking at the name here. I'm looking at AB over AC. and checking if it's the same as AE over AD. If those two ratios are true, then I know I did it right. So I got okay, or I know that these triangles are similar. So 4 is to 12 as 3 is to 9. Okay? So once again, that was AB over AC, checking that that's the same as AE over AD. And both of those actually do come out the same. It's both 1/3. So I say yes. So now you write your conclusion. So step 4, you conclude. Therefore, the triangles are similar by side, angle, side, similarity. Okay, so this is the gist of what I wanted you guys to get out of example 6. So hopefully you didn't have much problem with it, and now you can see the answer. If you missed anything, feel free to scroll back on the timeline because this is a video you can rewind. All right, have a nice day.